Hello and welcome to this video about how to solve by elimination. Now, what cues you in to use elimination as a way to solve? Usually you're going to see these problems presented as if they were in standard form for both equations, as we see here. None of the variables have been solved for, so you do have the option to use elimination. Also, the basic idea of elimination is that you can add equations together. So when I do add these two equations together, I'm going to be eliminating the variable of x. So this one's already really set up for what's called elimination. Let's go ahead and add these two equations together and see what happens. So when I see x plus negative x, that actually cancels, which is all sorts of cool. 3y plus 2y is 5y and equals 17 plus 8 is 25. Now I've created a new equation by adding the two previous equations together. It doesn't seem like that should work, but it does. So now I can divide by 5 on both sides and get that y is equal to 5. Alright, now, not only would I be able to do that, I would also be able to solve for x now since I know the value for y. Take either equation from the original and substitute 5 in for y. I'm going to use the x plus 3y equals 17. And what I'm going to do is I'm going to substitute 5 in for y. So it's going to be x plus 3 times 5 equals 17. This is very reminiscent of substitution because that's exactly what we're doing. We're using substitution to finish this off. 3 times 5 is 15. And subtract 15 from both sides. So x would equal 2, and this would be our solution. X equals 2, y equals 5. I did forget to mention that we were on page 154 with this, so you can get there and rewind the video and get that problem done if you need to. All right, with that said, let's move on to problem number 4 and see how we can use elimination on it. First thing I'm noticing on problem number 4, am I set up for going ahead and adding these equations? I am, because while the x's would not cancel, the y's are ready to cancel. So I am going to go ahead and add these two equations. 4x plus negative 1x is 3x. 3y plus negative 3y cancels out. That's eliminated, hence the name of the method. 6 plus 3 is 9. So 3x equals 9 is my new equation. Very easy to just divide by 3 on both sides and get that x is equal to 3. Now that I've got that, I'm going to go back, use either of the previous equations to figure out what y is. I'm going to personally use this first equation, the 4x plus 3y equals 6. You could have used the second one if you'd like to. Now I'm going to take the 3 and I'm going to substitute it in. So it's going to be 4 times 3 for x that we found previously, plus 3y equals 6. Now I can solve this equation for y. 4 times 3 is 12. I'm going to subtract 12 from both sides now. So I'm going to have 3y is equal to negative 6, and I'm going to divide by 3. And y is negative 2. So now I'm ready for my final answer, which is x equals 3, y equals negative 2. And we are finished with that one. All right, going on to page 155. What's going to happen sometimes is you have to multiply one of the equations in order to actually get something set up to cancel. So we're going to go ahead and take a look here at how to make that happen. I'm going to be looking at number 10 and number 11. Okay, so on number 10, what happens is when I'm looking at x and 2x, they will not cancel. 2y and y will not cancel. So I'm going to need to multiply one of the equations. I'm going to target the x values. That's just a personal preference here. I could have just as easily chose the y values. If I'm going to get these x's to cancel, I'm going to need to take this 1x and make it a negative 2x in order for it to cancel. So what I'm going to do is I'm going to take this entire first equation and multiply it by negative 2 and rewrite it down here as negative 2x, x times negative 2, 2y times negative 2 is minus 4y equals 20 times negative 2 is negative 40. Now, disregarding the top equation, now I've got something where the x will eliminate. Let's go ahead and see how that works. I'm going to go ahead and do this. 2x plus negative 2x cancels, so I'm adding here. Y plus negative 4y is negative 3y equals 19 plus negative 40 is negative 21. And now I've got an equation where I can solve it for y. So I'm going to divide by negative 3 on both sides and get y is equal to positive 7. Now what I can do is go back and use any of the three equations to figure out what x is. Use any of the three of them. I'm personally going to go with the x plus 2y equals 20, and I'm going to substitute the 7 in for y. I chose that one because I'll have nothing to divide by here in a little bit. So x plus 2 times 7 equals 20. 2 times 7 is 14. And subtract the 14 on both sides. I'll get x is equal to 6. So as my final solution here, I have the coordinate pair 6 for x, comma 7 for y. You always go in alphabetical order if they're ever using other variables. So if they're using the variables a and b, you'll use a comma b for that. All right, that goes into number 11 right now. So number 11, you have to start using least common multiples. So I can't just like multiply 3x and make it something negative 4x in order to cancel. I can't simply multiply negative 2y by something to make it negative 3y where it's going to cancel. What I'm going to have to do is I'm going to have to multiply both equations in order to get something to cancel. First step, I'm going to target one variable or another. I'm going to go ahead and target the y's to cancel, and that was just my personal preference. So what's going to happen is I'm going to consider the least common multiple of negative 2y and negative 3y to be 6y. So now I'm going to multiply the equations to make them 6y and negative 6y, and then that way they'll actually cancel. This is the most difficult form of elimination, is when something's not ready to go. All right, so if you get frustrated here, remember, it happens. Okay, let's go ahead and multiply this top equation by something to make it 6y. If I multiply it by 3, that's going to make it negative 6y, and that's going to be good news. Let's go ahead and do that. 3x times 3 is 9x. Negative 2y times 3 is negative 6y equals negative 2 times 3 is negative 6. Now what's going to happen is I'm going to try to find a way to make the second equation something that will make the y's cancel. Okay, so on the second equation, I'm going to again multiply it. Let's see here. If I'm going to try to cancel out negative 6y, I really want this one to become positive 6y. Let's make it happen. To make negative 3y positive 6y, I'm going to multiply everything by negative 2. And you can see the top one I multiplied by 3, the bottom one I multiplied by 2, so they're kind of mirroring each other is what they're kind of doing as far as your steps go. 4x times negative 2, negative 8x. Negative 3y times negative 2, positive 6y, exactly what I was hoping for, that way they'll cancel, equals negative 4 times negative 2 is positive 8. Now I'm ready for these equations to add together, and then I can go about my business of solving the system. So I'm going to go ahead and add these two equations together, and 9x plus negative 8x is 1x. Negative 6y plus 6y canceled, as it should have, and equals negative 6 plus 8 is 2. I'm actually already done here because I have nothing left to do to solve for x. X equals 2. Now I can go back and I can use any of these four equations to figure out what y is. Really up to me on what I want to use. I'm just going to use the top one. So I'm going to use 3x minus 2y equals negative 2. What's going to happen is I'm just going to drop this value of 2 in for x. So 3 times 2 minus 2y equals negative 2. And now I'm going to solve by 3 times 2 is 6. And I'm going to subtract the 6 on both sides. So negative 2y is equal to negative 8. And I'm going to divide by negative 2. So y is equal to 4. Now I finally got my answer for number 11. Number 11, I'm going to have my coordinate be 2, 4. X first, then y. All right, and that's it. That's really the basic, simple run-through of elimination. I haven't covered everything that possibly happens, nor can I. So if you have questions on the problem, please email me. Really appreciate it, folks. Thanks.